Alright, welcome back, YouTube, to the, welcome back. Welcome back to the series, I guess you could call it, is what I'm gonna call, that's what I'm gonna call it now, of the Desmos Graphing Calculator tutorial, where I show you how to make a calculator from the Desmos calculator, or whatever you want to call it. Yeah, so I have the original right here. You probably noticed the two tabs of the Google Sites. That's me editing. That's the editing tab. And then I have the actual tab so I can preview what it looks like. I have changed it to now say right triangle calculator, where it used to say right calculator tutorial. Since it says tutorials at the top, may as well just have it say may as well just have each group thing say what tutorial it's about. So, this one actually took a little bit of, this one actually took a little bit of time to do, because, well, when you input the parameters, it takes a little bit of time, because when I was getting the side lengths, I had to do two different slope triangles. It was not easy, but I did it. And it works. At first, it was kind of weird when you modified the numbers, but then I made it all just work so that it doesn't look weird. So, yeah. Anyways, let's get started. Sorry. So, I'm going to maximize this because I'm pretty sure in the last video I had maximized it. So, let's maximize it again. Let's start, shall we? So, yeah. First variable, x1 equals 5. y1 equals 5. x2 equals 15, and y2 equals 15. Now, I forgot what numbers I originally had on this, so I just went with what I had when I saved it, so, yeah. Then, and this is, actually very, very important, because it's for the top point. It's the x value. Now, you're probably thinking, why don't I just do x3, but I was bored and didn't really think fully, so I just did z1. Yeah. You want to set this to x2 minus x1, then divide that by 2. That actually gets the distance of the base, so it gets the length of the base, divides it by 2, and then sets that to the middle point, or whatever you want to call it. Yeah, middle point. So you have point 1, I guess, and point 2. Middle, right here, and then it sets it to that. That's how the isosceles part works with the 2 equal sides. That's how I did that. And now for the points. A1 is equal to x1, y1, obviously. A2 is equal to x2, y1. And since it's an isosceles, you have to have these two the same. Otherwise, it's not going to work. And then A3, which is the top point, it's going to be a2 dot x minus z1 dot, wait, hold on, not dot, and then y2. So, oh yeah, that gets, so you have y2, there we go, and then, so this is actually the distance, this part right here is actually the calculated distance of this and this. And then it just, so we have to then subtract it from this point and put it right there. Because otherwise it's gonna go from the origin and it's gonna go like that. So we want to make it so it's relative to this point. I mean, I could just do this point plus, but, I was just doing whatever. Or, I guess, I don't know. Now for the 2 points, these are actually not going to be shown on the graph because it is not necessary to show them on the graph. And I actually, in this, it is not visible because this is the part where we calculate the slope triangles for the hypotenuses of the two same sides. Don't ask why. But I decided to calculate both at the same time, even though it's an isosceles. I just decided to do it anyway. Because, hey, you never know. Might help catch an error in my calculator. Okay, so we're going to do A4. This is the start of the 2 points. So we're going to do A4 equals A1 dot X, A3 dot Y, A5 equals A2 dot X, and then A3 dot Y. Now, we're getting the X value of these two, then the Y value of this, and that's how you do that. Now remember, you gotta make them not visible, because it's not supposed to be visible. Now, these are not going to be coordinates. These, these next 4 variables, they're going to be they're going to be normal variables, nowhere near coordinates. This actually calculates the sides, not the hypotenuse of the slope triangles, the simple sides, so that we can then calculate the hypotenuse. And once again, absolute value. So A6 is equal to the absolute value of A3 dot X minus A4 dot X. And then A7 is equal to the absolute value of A5 dot X minus A3 dot X. A8 is equal to the absolute value of A4 dot Y minus A1 dot Y. And then A9 is equal to the absolute value of A5 dot Y minus A2 dot Y. And I'm not doing any special keybinds to do this. I'm just typing a number after the variable, and that's how I'm numbering all of them. And then this part, I do believe, is for the base, or is it for... Oh, this is the hypotenuse parts. Oh, yeah, okay. This is where we calculate the hypotenuse. Both the squared and the actual distance when unsquared. Or not unsquared, when not squared. So, and it's not going to be any variables. This is just calculating it and giving you the answer. So you have the absolute value of A6 squared plus A8 squared. And then you have the absolute square root of A6 squared plus A8 squared. Okay, so that's the absolute value of that. Now, for the other one. Because for some reason I decided to. Even though it's completely unnecessary. And actually, I think the top 4 are required. Or maybe not, I don't know. Probably aren't. Anyways, A7 squared plus A9 squared. That's the absolute value of that part. Because it may or may not be a negative. I have no idea if it's going to be or not. Now, the absolute square root of A7 squared plus A9 squared. And that is that. And now that we have all the, now this is all the math. This is what calculates everything for you. Now to help with the visualization. Create table. Now, just do A1. Wait, no, not A2 yet. Now I hope from the last video this helps you understand why I'm looping it again. And there. I just wanted to be silent for that because I just feel like I don't need to explain things while I'm clicking those. But at least now you get the... can see what I was doing. So yeah, it's the Isosceles right triangle. Oh my gosh, why do I keep saying that? Isosceles triangle. If you as you can see it, it works. Works perfectly. Now what? And as you can see, oh, not sorry. As you can see, you set the x of this, and it still gets the middle point. Y, still works magically. And, yeah, that's the isosceles. Hold on. What the? Okay, yeah, let's just pretend that never happened. Although you are able to just rewatch it, but let's just pretend you never saw that. Okay? Nice. Okay, well, that's the Isosceles Triangle Calculator. I hope you enjoyed the video. Like if you thought it was helpful, and maybe consider subscribing. It would help out the channel a bit. Bye, I guess. Have a good day or night, whichever it is for you.